right? So this is different, okay? This is the one step more complicated or different than what we did before. Can anybody see what's different about this than the first radical equations that we had? There's a variable that's not inside the radical, right? It's a radical equation because it does have a variable that's inside, but it also has a variable that's outside the radical. Okay. So let's see what happens when that's true. First, follow the same steps. Isolate the radical. What should I do to isolate the radical? Subtract 5. So the square root of x minus 3 equals x minus 5. Okay, undo the radical. Square both sides. Okay, square, square. Okay, square and the square root, they cancel each other out. And then what is x minus 5 squared? No. Remember, you can't keep making this mistake. It's not x squared plus 25 or minus 25. It's x minus 5 times x minus 5. It's a FOIL. You've got more terms than just x squared minus 25. Okay? X squared minus 10x plus 25. That's what you get when you FOIL that. Okay, now, what kind of equation is that? It's quadratic, right? So we have to remember, okay, well, how do we solve quadratics? First, we have to put them in the right format, which is, Ryan? We're not taking a root. We're squaring. You don't have to worry about it if you're just squaring something. Okay, what do I have to do so that I can solve this as a quadratic? It has to be equal to 0. It has to be standard form equals 0. So we need to, let's move the x minus 3 to the other side. Subtract x and add 3. Subtract x, add 3. And then we get 0 equals x squared minus 11x plus 28. At that point, you solve it, based on what it is. If it's factorable, then you probably factor it. This one is factorable. If it's even if it's factorable, but you can't see it, what's another way you could solve it? Quadratic formula, right? So you can solve anytime you get to that point. You should be able to finish it with the quadratic formula. This one is actually a pretty easy factor. What is it? Right? Just remember, it's a simple quadratic because it has a 1 in front of the x squared. So you just say what two numbers? The product is 28 and the sum is negative 11. Minus 7 minus 4. So x minus 4, sorry. So remember, the reason we do that, the reason we put it in factored form equals 0 is because we know that if a product equals 0, it's because one of the factors must be 0. So now we can just solve each factor. What value of x makes the first factor equal 0? 7. 7 minus 7 is 0. What value of x makes the second factor equal 0? 4. All right? So there's our two answers. But we're not done. Remember the last step. We've got to check our answers. So first, let's plug in x equals 4 and see what we get. The square root of 4 minus 3 plus 5 equals 4. That's a question mark. We don't know. We're checking it. The square root of 1 plus 5 equals 4. 1 plus 5 equals 4. That's incorrect, right? That doesn't check. When you solve a radical equation, oh, it does not check, sorry. Does not check. When you solve a radical equation and when you check it, the answer doesn't work out, that's called extraneous. X equals 4 is an extraneous solution. Yes, it did. It was part of solving absolute value equations too. And it happens at exactly the same spot. It's when you've got an absolute value equation that has a variable inside the absolute value and one that's outside the absolute value, then you can have an extraneous solution. Okay, which means it's not a solution, right? It's not a solution. We could check the x equals 7, plug in 7 minus 3 plus 5 equals 7, question mark. 4, the square root of 4 plus 5 equals 7. So that's 2 plus 5 equals 7. And that checks. So the only answer is x equals 7.